Every sunrise is ancient. Even the one you saw this morning, warming the rooftops, spilling gold over treetops, gently stirring the day awake, was light that began its journey long before your morning coffee ever brewed. It took tens of thousands of years just to escape the sun's dense interior, and only then did it race the final 93 million miles to kiss your skin in under 9 minutes. You are touched by something ancient every single day. We have always looked to the sun with awe. Before science, there were stories. The Greeks called it Helios, a radiant god driving a chariot of fire across the sky. The Egyptians saw it as Ra, the all-seeing eye of life and order. In Incan mythology, it was Inti, father of the world, born anew with each dawn. No matter the culture or continent, the sun was sacred. Not just a source of warmth, but a guardian of time, of harvests, of life itself. And just occasionally, animals grew silent and humans held their breath. What had they angered? Where had their god gone? Fires were lit, chants rose like smoke, and though the light always returned, it left behind a lingering sense that the sun was more than a glowing orbit, was alive, unknowable, watching. Centuries passed, and still we could only see the surface. Galileo watched it through darkened glass and drew sunspots, daring to sketch the blemishes on a divine face. Later, with prisms and telescopes, we began to break down sunlight into its spectral colors, realizing that this light held secret fingerprints of elements, clues to a hidden core. And yet, it remained distant. Even today, when we fly machines into space and gaze at plasma through high-energy sensors, the center of the sun remains an enigma. What churns there? What dances beneath that blinding veil? But perhaps what matters, it watches, and we, small creatures clinging to our rock, have watched right back. So tonight, as your room grows dim and the hush of evening settles in, let your mind wander. What does the sun mean to you? A childhood memory? A golden morning by the sea? A story whispered to you once? Tell me in the comments, or simply let the thought drift, because now we're going to begin. We're going deeper than we've ever gone, into the heart of the sun itself. Have you ever watched a sunrise slowly warm the earth? Watched as shadows softened, dew evaporated, and the hush of night gave way to a world stirring with life? Their compass and their calendar. Long before science, there was watching, waiting, wondering. In ancient Egypt, the sun was more than a light in the sky. It was a god with many faces. Ra, the sun god, traveled across the sky each day in his solar boat, battling darkness and chaos by night. Each dawn was a triumph, each sunset a reminder of the delicate balance between order and the void. Without the sun, life withered. Crops failed. Time itself unraveled. And in the valleys and highlands of ancient Peru, women rose with the sun to grind maize and watch the skies. The Inca built vast temples aligned with solstices, structures that told time, not with ticking hands, but with beams of light. And when the rains missed their cue, far to the north, in Celtic lands, the sun marked the cycle of seasons. The wheel of the year spun with each solstice and equinox, guiding when to plant, when to reap, when to rest. Stone circles like Stonehenge rose from the earth, monuments of memory and measurement. They weren't built in haste. They were built to honor something constant, something sacred, and yet as centuries passed, stories began to shift. Curiosity stirred. The sun was still divine, yes, but perhaps also understandable. In ancient China, philosophers wondered what it was made of. In Greece, thinkers like Anaxagoras dared to suggest the sun was a burning rock, bright, hot, distant. He was imprisoned for that idea, for suggesting that light could be explained, not just revered. And then came Galileo. In the early 1600s, he turned a telescope barely stronger than a child's toy today toward the sun. Risking blindness, he saw what few dared to look at: sunspots, dark blemishes that drifted and changed. Proof that the sun moved, that it was not perfect. It was a dangerous idea to say the sun was flawed, to hint that the heavens themselves were dynamic, perhaps even impure. But with each step from story to sketch, from temple to telescope, we crept closer, closer to the realization that the sun wasn't just watching us, it was speaking in light and shadow, in heat and rhythm. Imagine the hands of a woman pressing seed into sun-warmed earth, the shadow of her arm tracing time across soil. Picture the pulse of life, rising with each golden morning, and ask yourself, what secrets did the sun whisper to them? Long before we knew how to look. Have you ever watched a sunrise slowly warm the earth? Watched as shadows softened, dew evaporated, and the hush of night gave way to a world stirring with life? That quiet moment, gold slipping over the edge of the world, was once our ancestors' clock, their compass, their calendar. Long before science, there was watching, waiting, wondering. In ancient Egypt, the sun was more than a light in the sky. It was a god with many faces. The sun god traveled across the sky each day in his solar boat, battling darkness and chaos by night. Each dawn was a triumph, each sunset a reminder of the delicate balance between order and the void. People prayed not just for warmth, but for protection. Without the sun, life withered, crops failed, time itself unraveled. And in the valleys and highlands of ancient Peru, women rose with the sun to grind maize and watch the skies. The Inca built vast temples aligned with solstices, structures that told time not with ticking hands, but with beams of light. In many agrarian societies, women were the early timekeepers, their work and wisdom woven into the rhythm of light. They noticed when shadows lengthened too early, when the sun scorched too long, when the rains missed their cue. Far to the north, in Celtic lands, the sun marked the cycle of seasons. The wheel of the year spun with each solstice and equinox, guiding when to plant, when to reap, when to rest. Stone circles like Stonehenge rose from the earth, monuments of memory and measurement. They weren't built in haste. They were built to honor something constant, something sacred. And yet, as centuries passed, stories began to shift. Curiosity stirred. The sun was still divine, yes, but perhaps also understandable. In ancient China, philosophers wondered what it was made of. Greece, thinkers like Anaxagoras dared to suggest the sun was a burning rock, bright, hot, distant. He was imprisoned for that idea, for suggesting that light could be explained, not just revered. And then came Galileo. In the early 1600s, he turned a telescope barely stronger than a child's toy today toward the sun. Risking blindness, he saw what few dared to look at: sunspots, dark blemishes that drifted and changed. Proof that the sun moved, that it was not perfect. It was a dangerous idea to say the sun was flawed, to hint that the heavens themselves were dynamic, perhaps even impure. But with each step from story to sketch, from temple to telescope, we crept closer, closer to the realization that the sun wasn't just watching us, it was speaking in light and shadow, in heat and rhythm. And we, slowly, were learning to listen. So tonight, lie back and imagine the warmth of a field at noon. Imagine the hands of a woman pressing seed into sun-warmed earth, the shadow of her arm tracing time across soil. Picture the pulse of life, rising with each golden morning, and ask yourself, what secrets did the sun whisper to them? Long before we knew how to look. Imagine trying to understand a giant ball of fire, using only glass, patience, and a notebook. That's exactly what they did. The rise of solar science didn't begin with thunderous discoveries or flashy machines. It began with people who dared to look carefully, curiously, into a sky most others simply admired or feared. It began with small pieces of glass, shaped by hand, held to the heavens. By the early 1600s, telescopes were beginning to change the way we saw everything. Astronomers, once just sky watchers with stories, were becoming investigators. Galileo was among the first to use this new tool to observe the sun, revealing sunspots, those mysterious blemishes that shifted over days. These dark spots weren't imperfections. They were windows into the sun's swirling storms, and yet to glimpse them meant danger, eyesight lost, pain endured. And still they looked again. In the centuries that followed, others joined the quiet pursuit. In Germany, Samuel Heinrich Schwab devoted decades to tracking sunspots. Every clear day, for over 17 years, he documented the sun's changing face in delicate sketches. No grand laboratories, no computers, just sunlight. His persistence revealed the solar cycle, a rhythm of rise and rest in the sun's activity, pulsing every 11 years. And then came the tool that allowed scientists to split sunlight into its full spectrum, revealing colors too rich for the naked eye. Through this rainbow, scientists began to listen to the sun in a new way. Each line, each hue, whispered something specific: the presence of hydrogen, of helium, of elements forged in the furnace of stars. This is where women began to quietly revolutionize the field. At Harvard Observatory in the late 1800s, Annie Jump Cannon joined a group of women known as computers. They were hired to analyze starlight using spectrographs, systematically classifying stars by their spectral fingerprints. Annie's eyes became sharper than any lens. She could identify a star's type in seconds, and over her career, she classified hundreds of thousands of them. Her work laid the foundation for how we understand stars, even our sun today. And then there was Cecilia Payne. In 1925, as a young doctoral student, she used spectral analysis to reach a radical conclusion: the sun is made mostly of hydrogen. It seems obvious now, but at the time, it shook the foundations of astronomy. Until then, many believed the sun was similar in composition to Earth. Cecilia saw deeper. Her quiet, careful work showed that stars were not just distant rocks, they were entirely different worlds, built from the lightest of elements, blazing from within. The tools were evolving: telescopes more precise, spectrographs more sensitive, but it was the people behind them, their minds and hearts and hands that pushed the light into meaning. Tonight, as you close your eyes, picture those a woman at a desk, surrounded by plates of rainbow lines. A man squinting through smoke-blackened glass, sketching a shadow across the sun. They didn't just see the light. They read it like a letter from the universe. And as they read, the sun's secrets began to unfold gently, line by line, like a whisper drifting from one century to the next. Have you ever looked at something glowing, still, and felt there was more underneath? The sun is like that too. By the early 20th century, humanity was no longer content with just looking at the surface of the sun. We wanted to feel its pulse, understand its breath, see not only what shimmered on the outside, but what stirred within. This curiosity led us upward to mountaintops first. High above the haze of city lights and atmospheric blur, scientists built observatories solely devoted to the sun. These places, like the Mount Wilson Observatory in California, became sanctuaries for solar discovery. There, through clear skies and long days, astronomers followed the dance of sunspots, flares, and filaments. Quietly, patiently, they learned to read the language of light more fluently. But Earth has limits. Even atop the highest peaks, we still look through layers of air, and air, however thin, ripples and bends the sun's messages. So, in the later half of the century, we did what once sounded like myth. We left the planet behind. Satellites became our new solar eyes. SOHO, the Solar and Heliospheric Observatory, launched in 1995 and still floating quietly in space, offered us a front-row seat to the sun's rhythm. It watched solar storms erupt and particles stream. It saw the solar wind, a constant breath of energy, leave the sun and ripple through the solar system. Through SOHO, we began not just to see the sun, but to listen to its mood. Then came Hinode from Japan, offering close-up views of the sun's magnetic dance, and stereo twin spacecraft flanking the sun like bookends, giving us a three-dimensional view. Together, they created a symphony of perspectives, each one helping us understand the sun, not as a flat image in the sky, but as a living, breathing sphere of energy. What we saw was ... mesmerizing. The sun, from afar, looks gentle, soft, a round, unwavering glow. But up close, through the eyes of these satellites, we found layers upon layers of motion and mystery. There's the photosphere, the sun's surface. Though surface is a loose word, it's more like the visible skin of an onion, rippling with granules that last just minutes before dissolving. Each granule is a convection cell, hot gas rising and cooler gas falling, like a boiling pot too big for the mind to grasp. Above that floats the chromosphere, a fleeting veil of pink and red, rarely seen unless a solar eclipse briefly lets it whisper into view. It's a place of flares and surges, of energy darting like quicksilver. And beyond that, the corona, the crown, a ghostly halo of plasma stretching millions of miles into space. You can't see it during a normal day, but during a total eclipse, it spills out in tendrils, dancing with magnetic tension. It's hotter than the surface below it, a mystery still unsolved, like mist that glows with fire. And yet all of it, the layers, the storms, the waves of energy, from a distance, it looks serene, peaceful, a lantern hung in velvet sky. The irony is gentle. The more we see, the more we learn how restless the sun really is. Underneath its stillness, it churns, it pulses, it changes in cycles. Like us, it has moods. Like us, it has seasons. So tonight, as you drift towards sleep, think of the sun not as a fiery ball, but as a layered poem, skin and mist, breath and storm. A star whose glow touches every leaf, every tide, every heartbeat, and in the next breath of thought will follow its light further to the very storms it sends across space, to where sunlight becomes wind and wind becomes weather in the sky between stars. Would you fly into the sun if it meant unlocking the universe's secrets? Parker did. In 2018, from a quiet launch pad in Cape Canaveral, something extraordinary began. The Parker Solar Probe, a small but resilient spacecraft, lifted off into the night sky, not to orbit Earth or even visit a distant planet, but to journey straight into the heart of light. It was the first mission to touch the sun, not with hands or feet, of course, but with its body, its sensors, its silent instruments. Parker would slip into the corona, the sun's wispy outer atmosphere, and feel what no other machine had felt. It wouldn't just observe from afar. It would immerse itself in sunlight itself. You might imagine a fiery plunge, violent and fast, but Parker's path is more like a dance, a delicate spiral, slow and patient. It uses Venus, Earth's planetary sibling, to gently curve its orbit inward, like a swimmer slowly circling the drain of gravity. With each pass, Parker swoops closer to the sun, kissing the corona more deeply, learning more intimately to protect its fragile inner heart. Engineers wrapped it in a heat shield like no other, a black disk, thick but elegant, facing the sun at all times. It stands like a lotus leaf against the fire, deflecting temperatures that would melt steel, while the spacecraft behind it remains cool, cold enough to touch. Inside, Parker carries instruments that listen to the solar wind, that feel the electric fields dancing through space, that tastes the particles moving at unimaginable speeds. It is, in many ways, not just a machine, but an envoy, a question in motion. But there's something more poetic here, something deeply human. For centuries, we've watched the sun from the ground. We've studied its light, measured its cycles, told stories about its moods. But never before had we dared to fly directly into its reach. Parker does what poets have only dreamed of. It approaches the source of warmth, the giver of life, the celestial body that shaped our calendars, myths, and rhythms. The probe is named after Eugene Parker, a solar physicist who, in the 1950s, proposed the existence of the solar wind. His ideas were dismissed at first, laughed at, but time proved him right. And when NASA launched this daring mission, they did something unprecedented. They named it after a living person. Eugene, old and gentle, watched his namesake rise toward the star he had loved in silence for decades. In the quiet of space, Parker flies alone. It does not send pictures. The sun is too bright. Instead, it gathers data, wind speeds, plasma waves, magnetic whispers. Each orbit, it gets closer. By 2025, it will fly within 4 million miles of the sun's surface, unimaginably close. Considering Earth floats 93 million miles away, at that distance, sunlight isn't gentle. It's a furnace, and yet Parker endures, glides, whispers back its findings to us on Earth. It tells us how solar storms begin, why the corona burns hotter than the surface. It teaches us what light feels like when you're inside it. There's something quietly emotional about that. This small probe, no bigger than a car, carries humanity's longing toward the core of brightness. It's not just about science. It's about wonder. It's about having questions so deep that we risk everything to find the answer, even flying into fire. As you rest tonight, imagine yourself aboard Parker, surrounded by glowing winds, shielded from the heat, floating just beyond the surface of a star, feeling the heartbeat of light. And in the next chapter of this slow journey, we'll follow those very winds, tracing how solar breath becomes space weather, touching not just the edge of Parker, but eventually touching us. The sun breathes, did you know? Its breath reaches us every day, and sometimes it sings from the quiet, lonely orbit where the Parker solar probe glides. We've begun to hear that breath, not in sound, not with ears, but in pulses and patterns, in the rhythm of charged particles that flow from the sun like an invisible tide. This is the solar wind, and for the first time, we are not just feeling it, we are inside it. Imagine the solar wind like the slow exhale of a sleeping giant, constant, flowing, sometimes gentle, sometimes fierce. Parker felt it, not as a breeze, but as a stream of charged particles, protons and electrons set loose from the sun's upper atmosphere, drifting and darting through space. This wind can take days to reach Earth, but its journey begins just beyond the corona, where Parker now listens. One of the most unexpected things Parker discovered were sudden reversals in the direction of the solar wind, like flicks of a ribbon caught in a gust. Scientists had predicted steady flows, smooth and continuous, but Parker showed us something more chaotic, more beautiful. These switchbacks twist and curl like dancers mid-spin, like ripples in a pond disturbed by a gentle stone. They tell us that the sun's breath is not steady, it's alive. And then there are the magnetic fields. Parker found that the sun's magnetic forces stretch and bend across space-like strands in a loom, weaving the fabric of our solar system. These threads don't just sit still, they snap, reconnect, spiral, like breath through a flute, carry harmony and discord alike, and sometimes they break into storms. When these forces tangle and release, they send great pulses of energy toward us. We call them solar storms. On Earth, they can disrupt satellites, cause power grid failures, or more beautifully, paint the sky in colors. The auroras you may have seen dancing at the poles are not random. They're signatures of the sun's whisper, etched in green and violet across our atmosphere. Through Parker, we've learned that space isn't empty. It's filled with the sun's touch, a gentle presence moving outward in every direction, brushing planets, moons, and everything in between. Understanding this touch means understanding how we are all connected to our star, not just by light and warmth, but by motion and mood. Each particle Parker measures is like a message, a tiny note in the long song of the sun. It tells us how the corona stays so hot, how the wind escapes gravity, how the sun changes over time. These are questions we've asked for centuries, and now, at last, we are beginning to hear answers. But perhaps most profoundly, Parker's findings remind us that the sun is not just a distant ball of fire. It is a living, breathing part of our cosmic neighborhood, one whose breath shapes our sky, our weather, and even our sense of wonder. Close your eyes and imagine those threads, the switchbacks, the winds, the magnetic flows swirling gently around you. They've traveled millions of miles to be here, to meet you. And in Parker's data, in its quiet communion with sunlight, we find poetry in physics. In the next chapter, we'll follow those flows outward to understand how solar storms ripple across space and how Earth, so far away, prepares for the sun's next whisper. Have you ever watched a flame move in slow motion? Now imagine it's the size of a planet, high atop the sacred slopes of Haleokleb in Maui, Hawaii. A silent watcher peers at the sun with clarity unmatched by any eye before. The Daniel K. Inouye Solar Telescope, a marvel of engineering and reverence, was built not to conquer the sun, but to understand its shimmering skin in intimate detail. What it sees is astonishing. Gone is the smooth yellow disk we glimpse from Earth's surface. Instead, the telescope reveals a roiling ocean of light, vast cells of plasma rising and falling in slow, rhythmic patterns. Each granule you see in its images is about the size of Texas, shimmering like molten gold caught in a web of magnetic energy. It looks, somehow, alive. Through Inua's powerful gaze, the sun's surface appears to boil, its convective motions pushing heat outward like the slow breath of a giant. These cells, called granules, form and fade like thoughts. Watch them closely, and you'll begin to sense a pattern. The universe doesn't just expand in silence. It pulses, it stirs, it beats like a heart. But the beauty lies not just in the heat and motion, it's in the silence. These images don't roar. They glow, they ripple in slow motion, like sunlight dancing on water or honey stirred in a bowl. Through Inouye, we're not only seeing the sun more clearly than ever before, we're seeing it more tenderly, as if it's less a burning god in the sky and more a living body, intricate, vulnerable, breathing. And just like that, we begin to wonder if we can see this much from Earth. What secrets might still be hidden beneath the glow? In the next chapter, we'll return to space to follow the sun's temper, its storms, and its long-distance whispers that touch our world. The sun touches your life in more ways than light alone. It watches over your signals, your skies, your sleep, most days. It's easy to forget that the sun is not just a glowing dot in the sky. It's an active, breathing force, sending ripples of energy across the solar system. Every moment, it sheds a stream of charged particles, what we call the solar wind, and occasionally it erupts with flares or coronal mass ejections. These are the sun's tempests, invisible to us but powerful enough to cross millions of miles and still shake the edges of our small world. When these solar winds collide with Earth's magnetic field, they dance, sometimes gently, sometimes with force. They interfere with satellite communications, distort GPS signals, and, in rare storms, can even knock out electrical grids. It's humbling, isn't it, that something so far, so ancient, can still reach down and switch off our lights. But this connection is not only one of danger, it's also of beauty. When solar particles meet our atmosphere, they paint the sky. The auroras, northern and southern lights, shimmer in greens, pinks, and purples, soft curtains of light moving in silence. For centuries, people have seen them as omens, messages, or blessings from the heavens. They are the sun's whisper, transformed into a lullaby of color. We study the sun not only to predict its moods, but to understand the delicate balance that holds our modern lives together. A satellite beam guiding your map, a power line humming through your city. Even the calm rhythm of your sleep, tuned to cycles of light and dark. These are all strands in the web of space weather. And through this web, we realize the sun is not just distant fire. It's an ancient presence, still shaping our days in quiet, invisible ways. So next time you feel warmth on your face, remember that light left the sun 8 minutes ago, crossed 93 million miles, and arrived just in time for you. In the next chapter, we'll journey deeper into what all this means for our future, and how understanding the sun may help us protect life on Earth. We have journeyed to the sun's surface and even dipped into its fiery breath. But how do we see a place we can never reach? How do we know the secrets of its core, buried beneath a million miles of churning plasma? We do it not with our eyes, but with our ears. We listen. The sun, you see, is not silent. It is humming. It rings like a colossal bell, vibrating with waves of sound that travel deep into its heart and back out again. These are not sounds you could hear in the vacuum of space, but rather rhythmic pulses, oscillations on its surface that scientists can measure with incredible precision. This is the field of helioseismology, the study of the sun's earthquakes, its inner vibrations. Imagine tapping on a drum. By the richness of the sound, you can tell something about its size, its shape, the tension of its skin. In the same way, by listening to the sun's deep, slow resonance, we can map its hidden interior. We can feel the boundaries between its layers. We have learned that its core, where the fire is born, spins faster than its surface, a spinning top nested within a boiling sphere. We have felt the slow, majestic currents of its convection zone, where energy takes hundreds of thousands of years to rise to the light. This is a different kind of seeing. It is not about images, but about rhythm, about pattern. Through these vibrations, we have felt the sun's heartbeat, a slow, steady pulse that has beaten for 4.5 billion years, turning hydrogen into light, light into life. So tonight, as you listen to the quiet hum of your own world, imagine another, deeper hum, the silent music of our star, a song of pressure and time, whose notes tell us the story of what lies beneath the fire. And in the next chapter, we will take that understanding and look outward to see how our sun sings in the grand choir of the galaxy. For a moment, let's leave our sun behind, float up out of our solar system, and look back. From here, our star is just one of many, a single steady spark in a river of light we call the Milky Way. There are hundreds of billions of other stars in our galaxy alone. Some are violent blue giants, living fast and dying young. Others are dim red dwarfs, sipping their fuel so slowly they will burn for trillions of years. And then there is ours, a calm yellow G-type star. Not too big, not too small, not too hot, not too cool. In the grand cosmic city, our sun is not a flashy monument. It is a quiet, reliable hearth, and that is what makes it so precious. Its steadiness is what has allowed life on Earth to unfold in its slow, unhurried way. Its gentle light is the perfect energy for photosynthesis, for the patient turning of seasons, for the delicate balance of our world's ecosystems. We are here because our star is, in a cosmic sense, gentle. By studying our sun so intimately, we learn to read the stories of all the others. The light from a star 1,000 light-years away carries the same elemental fingerprints that Cecilia Payne first discovered in our own. The ripples on its surface tell of a heart that beats in a similar way. Our sun is our Rosetta Stone for the universe. It is our guide to the sky full of suns, each with its own planets, its own possibilities, its own silent story. Think of it. Every star you see in the night sky is a sun to another distant world. Each one is a source of warmth, of gravity, of wonder. Our connection to our sun is not unique. It is universal. It is the bond between a star and its children, played out 1 billion times over across the quiet expanse of space. Every story has an ending, even the story of a star that feels eternal. The sun, which has nourished our world for so long, will not burn forever, but its end will not be a sudden crash or a violent explosion. It will be a slow, graceful, and magnificent transformation, stretched across a timescale too vast for us to truly feel. In about 5 billion years, the hydrogen in the sun's core will finally begin to run out. The delicate balance of pressure and gravity that has held it steady for so long will falter. The sun will begin to change. It will swell, its outer layers expanding outward in a final, grand exhale of light. It will become a red giant. Its skin will cool and redden, but its size will be immense, growing large enough to swallow Mercury, then Venus, and perhaps even our own Earth. It will be a lantern in the sky, so large it fills the horizon. It will not be a death, but a culmination, the last, most glorious chapter of its life as a star. After a few million years in this state, its final act will begin. The sun will shed its outer layers, puffing them away into space like a dandelion releasing its seeds. This material will form a beautiful, intricate cloud of gas and dust known as a planetary nebula, one of the most stunning objects in the cosmos. It will be the sun giving its essence back to the galaxy, and at the center of that glowing shroud, a heart will remain, a small, superdense core of carbon and oxygen, no bigger than Earth, but incredibly hot. This is a white dwarf, the glowing ember of a once great fire. It will no longer create new heat, but will simply spend the next 1 trillion years slowly, quietly, cooling down until it becomes a cold, dark crystal, a diamond in the velvet dark. This is the sun's long goodbye, a story not of an end, but of a return. The very elements it forges will one day mix with other clouds in space and begin the cycle anew, forming new stars, new planets, and new possibilities for life. We have learned the sun's moods, its whispers, its ancient history, and its distant future. And now we are learning to anticipate its next breath. We are becoming space weather forecasters. This isn't about predicting rain or clouds. It's about predicting the flow of energy and particles from the sun that can touch our world. For this, we need more than one point of view. While Parker's solar probe bravely flies through the solar wind, another silent guardian watches from a different angle, the solar orbiter. Launched by the European Space Agency, the solar orbiter is on a daring, tilted path. It is the first spacecraft designed to get a clear view of the sun's poles. Imagine trying to understand Earth's weather by only ever looking at the equator. You would miss the whole story. For decades, we have only seen the sun's middle. The orbiter is changing that, giving us a top-down view of the regions where the solar wind is born and where its powerful magnetic fields originate together. These missions, Parker, Inwa, Solar Orbiter, and others, form a network, a web of sentinels watching the sun from every angle. They measure its magnetic field, watch for the telltale signs of a coming storm, and track eruptions as they race across the 93 million miles to Earth. Their goal is to give us warning. Days, or even just hours, can make all the difference in protecting our power grids, our satellites, and the astronauts who travel beyond our planet's shield. It is a quiet, profound collaboration. We are learning to live in harmony with our star, not by taming it, but by understanding its rhythms. We are learning to read the faint ripples on its surface and know when a great wave might be on its way. It is humanity's way of looking up at the sky, just as our ancestors did, and asking a very old question in a very new way. What will the weather be tomorrow? Have you ever noticed how different fires can be? And not every star is the same. Our sun is a G-type main sequence star, but it is, for us, the perfect flame. It is stable. For billions of years, it has burned with a remarkable consistency, its output of light and heat varying only slightly. It is not a violent, unpredictable star that would scorch or freeze a young planet. It is a steady, reliable hearth. This steadiness creates what scientists call the habitable zone, or more poetically, the Goldilocks zone, an orbit not too close and not too far, where water can remain liquid. Starlight into life. A hotter, bluer star would flood a planet with harsh ultraviolet radiation, making life on the surface difficult. A cooler, redder dwarf star would require a planet to orbit so closely that it would become tidally locked, one side forever baked and the other forever frozen. Our sun is different. It is a gentle star. Its light is nourishing. Its rhythm is patient. The slow, miraculous story of life on Earth, from the first single cell to the vast, teeming biosphere we know today, was only possible because it unfolded beneath this perfect, quiet flame. Our existence is a testament not just to our world, but to the gentle nature of our star. And yet, for all its steadiness, there are moments when this gentle star participates in an act of impossible celestial geometry. A moment when the moon, 400 times smaller, slides perfectly across its face from our point of view. A total solar eclipse. For a few brief, surreal minutes, the world holds its breath. Day turns to twilight. The temperature drops. Birds fall silent. And where the bright disk of the sun once was, a black hole hangs in the sky, rimmed with a crown of ethereal, pearlescent light. This is the corona, the sun's ghostly atmosphere, which we saw Parker fly through. During an eclipse, it is revealed to us on Earth in all its glory. What was once a source of terror for our ancestors has become a moment of profound connection and discovery. In the 19th and 20th centuries, scientists chased eclipses across the globe, using those fleeting moments of darkness to study the sun's composition and prove Einstein's theory of relativity, showing that the sun's immense gravity could in fact bend the light from distant stars. But beyond the science, there is the wonder. In the path of totality, strangers gather on hillsides and in city parks. They share special glasses. They watch together as the last sliver of sun disappears and the corona bursts into view. For a moment, all human concerns fall away, replaced by a shared, silent, collective gasp of awe. The sun's shadow does not just bring darkness, it brings us together. It reveals the hidden beauty of our star, and it reminds us that we are all just passengers on a small rock watching a cosmic dance of unimaginable grace. Science is one way to see the sun. Art is another. For as long as we have looked up, we have felt an urge not just to understand the sun, but to capture its essence, to translate its light into something we can hold. Think of the cave paintings at Lascaux, where ancient sun symbols suggest a primal reverence. Think of the swirling, incandescent yellows in Vincent van Gogh's wheat fields, where the sun is not just an object in the sky, but a living, breathing force of almost manic energy. Or the hazy, atmospheric light in J.M.W. Turner's seascapes, where the sun dissolves into mist and water, becoming a mood, a feeling. Poets have called it the eye of heaven, the golden chariot, the terrible torch. Musicians have written symphonies to its rising. Architects have built cathedrals that are designed to catch its rays, turning stone into sanctuaries of colored light. Each of these is a form of observation, as valid and as human as a spectral analysis. They are attempts to answer the same fundamental questions. What is this light? How does it make us feel? What does it mean to live beneath such a star? Science gives us the sun's physical truth, its composition, its mechanics, its future. But art gives us its emotional truth. It explores the sun's warmth, its hope, its melancholy, its fierce and undeniable beauty. Together, they form a more complete picture, a dialogue between our curiosity and our soul, as we continue to gaze at the fire in the sky. Once you truly understand your own home, you begin to see the possibility of home everywhere you look. Our deep knowledge of our sun has become our guide in one of humanity's most exciting quests. The search for other worlds. We look for stars like ours, calm, steady, and long-lived, and then we watch them patiently. We look for a telltale sign, a tiny, almost imperceptible dip in the star's light, repeating at regular intervals. This is a transit, the shadow of a planet passing in front of its sun. It is like watching for a solar eclipse on a star hundreds of light years away. From that faint dimming of light, we can deduce so much: the size of the planet, its distance from its star, whether it lies within that gentle, life-sustaining Goldilocks zone. The James Webb Space Telescope can even analyze the starlight that passes through the planet's atmosphere, tasting it for the chemical signatures of water, methane, or oxygen. Faint whispers of a potentially living world. Every exoplanet we discover is a testament to what we learned from our own sun. It is our template, our control group, our home base from which we explore the cosmos. We are, in a sense, looking for reflections of our own solar system. There is a quiet hope in this work, a belief that what happened here, the formation of a gentle star, a temperate planet, and the slow dawn of life, might not be a singular miracle. That across the galaxy there are other dawns on other worlds waiting to be seen. Our journey is almost at an end. We have traveled from myth to molecule, from the sun's fiery heart to the farthest reaches of its future. We have seen it as a god, a clock, a cosmic engine, and a work of art. But what is the final truth? It is this: there is an unbroken thread of light that connects you at this very moment to the beginning of everything. The hydrogen that fuels the sun was born in the Big Bang. That hydrogen was pulled by gravity into a spinning cloud that ignited into our star. For billions of years, the sun has fused that ancient element into new ones, releasing light and energy. That light traveled across space, warmed a small, rocky planet, and nourished the first life. That life evolved, watched the sun, built temples to it, and eventually telescopes. And that same light from that same star is falling on your world right now. It is the energy in the food that gives you strength. It is the warmth that holds our planet's climate in a delicate embrace. It is the rhythm that defines your waking and your sleeping. You are not separate from this story. You are a part of it. The iron in your blood and the calcium in your bones were forged in the hearts of stars that lived and died long before our sun was born. And the light that allows you to see the world around you is the sun's own ancient breath. The story of the sun is the story of you, and the light goes on. The sun is still shining, quietly, constantly, just as it has for billions of years, long before your first breath and long after your last. Its light, so familiar, has never stopped reaching us. Even now, as you lie in the quiet, eyes closed or heavy, the Parker Solar Probe continues its long arc around that brilliant star, brushing closer and closer, listening to the solar winds, gathering warmth, wisdom, and wonder. In all our seeking, we haven't tamed the sun, but we've touched it. And in doing so, perhaps we've touched something within ourselves too. Because what draws us to stare at the sky? What ancient hunger makes us ask what's out there? Maybe it's the same thing that made our ancestors draw sun spirals on cave walls. Maybe it's not about controlling the light, but simply honoring it, letting it remind us that even in darkness, something burns steady and bright. We've seen inside the sun now, through satellites and telescopes, lenses and code. We've read its waves, mapped its breath, watched it ripple like water, burn like memory. And the more we see, the more we understand. The sun doesn't just warm us, it connects us, powers our gardens, charges our rhythms, pulls on the compass of our dreams. And so our journey comes full circle. We have traveled from ancient myths to the sun's fiery corona, listened to its hidden heartbeat, placed it among its stellar kin, and watched its slow, graceful fade into the distant future. We have seen it as a god, a puzzle, a living machine, and a cosmic engine. But now, just for a moment, forget it all. Step outside, find a patch of sunlight, let it warm the back of your hand, close your eyes. What do you feel? That warmth is the echo of a nuclear fire that has been burning for longer than our species has existed. That light is the end of a journey that began tens of thousands of years ago, deep inside the sun's core. It is the same light that guided the Inca, that Galileo sketched, that Annie Jump Cannon classified, and that Parker now flies through. It is the breath of a star, made tangible. The sun is not just a distant object of scientific study. It is woven into the fabric of your life. It is in the food you eat, which grew by its light. It is in the oxygen you breathe, released by plants that worship it. It is in the rhythm of your day and the quiet of your night. Every ancient story, every modern discovery is contained in that simple, gentle warmth on your skin. You are, in a very real sense, a child of the sun, touched by something ancient every single day. The deepest we have ever seen into the sun is not through a telescope or a probe. It is in the realization that its light is not just out there in the sky. It is right here in your hand. It is within you. And it is a gentle story of light, fire, and wonder that never, ever ends. Tonight, you've walked alongside scientists and stars. You've drifted through auroras, peered into fire, and touched the edge of the unknown, all from the comfort of your room. That's the beauty of these stories. They start with light and end in rest. So if you're still with me awake, thinking, I hope something small inside you is glowing a little more softly now, and if you're already drifting, let that warmth carry you. The sun will still be there when you wake, and I'll be here, waiting to tell you more. If you'd like more quiet stories of stars and sky, consider subscribing. Until then, sleep gently beneath the light.